This is Challenge 3 from MoonLog. Before showing our project, we'll begin with some context. In Challenge 1, we designed a launch system to transport lunar regolith across Moontown. In Challenge 2, we developed an autonomous lunar truck distribution system. For Challenge 3, we designed one key transportation zone in detail, the mining and manufacturing facility, which converts raw regolith into the construction materials that support Moontown's growth. This map shows Moontown's layout and transportation network. Lunar regolith arrives at the launching zone, moves to the distribution center, then to the mining and manufacturing facility. After being processed into construction bricks, they're distributed to the resettlement center and farm. Designing the facility, we needed to account for several environmental challenges unique to the moon. These include extreme temperature fluctuations, abrasive lunar dust, reduced gravity, the absence of breathable oxygen, and limited water resources. Surface hazards also exist with steep inner wall slopes, uneven and rocky terrains, and concentrated dust accumulation on crater floor. Each of these factors influence the design of our station, materials, and operational systems. While developing the manufacturing facility, we identified 3 key user pain points. First, crew members may spend long periods waiting during the brick manufacturing process, with limited opportunities for rest or recreation. Second, supervisors require specialized knowledge to operate and configure robotic systems. Finally, maintenance staff need safe access to manufacturing equipment when repairs or servicing are required. To address these issues, we included a dedicated staff zone where crew members can rest, monitor operations, and access entertainment while manufacturing takes place. For robotic operations, we designed the system with pre-programmed functions and a simplified control interface to reduce training requirements and minimize human error. Finally, controlled access maintenance zones equipped with tools, spacesuits, and adjustable oxygen flow allow staff to safely carry out repairs while conserving resources.
Our station consists of several interconnected systems, which are airlock loading bays for safe cargo movement, a distribution network connecting to Moontown's transport system, a stop zone with amenities, surveillance, equipment storage, and spacesuit access, an automated brick manufacturing system, a verification scanner for quality control, and a robotic loading system to prepare cargo for distribution. Moving on, our transportation network operates using 3 dedicated truck loops. The first loop is Truck 1 transporting raw regolith from the distribution center to the manufacturing facility. The second loop, Truck 2, delivers finished regolith bricks to the resettlement center. And Loop 3, Truck 3 delivers finished regolith bricks to the farm. By separating these routes, all 3 trucks can operate simultaneously, increasing efficiency and reducing delays across Moontown. This floor plan shows how the station is organized across 5 zones: unloading, manufacturing, verification, loading, and stop zone. Separating these functions keeps materials, vehicles, and personnel moving efficiently while minimizing contamination risks.
To further develop and communicate our concept, we also created a physical prototype of the facility. This helped us better visualize the layout, user journey, and interactions between unloading, manufacturing, verification, and loading systems within the station. Now, let's move on to the user journey. The journey begins at the launching zone, where loose regolith is transported to the distribution center for sorting and preparation. Truck 1 collects the regolith and delivers it to the mining and manufacturing facility, entering a sealed airlock unloading bay to prevent dust contamination and protect workers and equipment. A vacuum extraction system transfers the regolith through sealed pipes into the manufacturing system, minimizing dust, release, and material loss. Inside, the regolith is compressed into molds and sintered into construction bricks, before being cooled in a controlled environment and prepared for distribution. Each brick passes through a verification scanner that checks quality, quantity, and identification data before shipment. The finished bricks are then stacked onto pallets by a robotic arm and loaded into a lunar truck using a forklift system. The trucks then move to a compressed regolith brick storage facility to avoid excess at other stations. When needed, Truck 2 and Truck 3 collect the pallets from storage and deliver them to their dedicated destinations. Truck 2 services the resettlement center, while Truck 3 services the farm, both operating on dedicated transportation loops to ensure a reliable and continuous supply chain across Moontown. Finally, the bricks arrive at their destinations, where they are used as primary construction materials to support new infrastructure, expansion projects, and the continued growth of Moontown.
Material selection was critical to ensure long-term operations in the lunar environment. Aluminum alloys are used for the structural frame due to their lightweight and thermal properties. Titanium alloy reinforced high-stress components requiring additional strength. Inconel is used in sealing systems for its resistance to temperature extremes. Sinter regulate the brick from the outer shell and wall, reducing the need for imported materials. Regulate geopolymers on structural components together. Aerogels insulations protect the station from extreme temperature fluctuations. We can evaluate accessibility, loading operations, maintenance requirements, and overall usability. MoonLog is a B2B logistics and manufacturing service, supplying construction operators within Moontown. We convert local regolith into construction-grade bricks and deliver them via our lunar trucks network. The revenue comes from a long-term contract with construction developers covering brick supply and delivery. This creates a reliable construction supply chains that support rapid settlement expansions, improve efficiency, reduce astronauts' exposure to hazardous environments, and enables sustainable growth using local resources.